Hello everyone, welcome to the second part of this video series called From Dev to Production on AWS. In the previous part, we saw how we can deploy our project using Flask for the backend and a database on localhost on our own device. In this video, we are going to see how we can deploy the containerized Docker image on AWS. So without losing the time, let's start with the first step. So, just like any other lecture, first I'm going to start with the theory of this architecture. As we saw in the previous video, it was super easy to run a container of a Docker image on localhost. All we need to do was just write one command in the terminal. But deploying the same Docker image on AWS requires knowing a little bit more. In this video, I'm going to try my best to explain all of the services, and also we are going to see a little bit of communication. I'm going to create a VPC, I'm going to create subnets. So if you don't have the knowledge on how communication happens inside of AWS, I strongly suggest you to go and watch the part 1 of my other course called Master Your VPC on AWS. It's a very short lecture. It shows you almost anything that we're going to cover in this video, and it's really helpful to understand how also the communication is happening inside your AWS account. So let's start with the architecture. So this is the simplest form of any architecture that we could find, right? Because our goal is to just deploy one container on AWS and have users be able to reach them. But there are a couple of notes here. As we can see, in order to deploy a backend which is written by Flask in Python, first we need to create a VPC. VPC is basically a network which we define. Inside of it, we can declare which service can communicate with which other services. And then inside that VPC, we have a public subnet. Again, I strongly suggest you to go and watch the first part of the other course to get more hands-on experience on what these terms mean. But overall, for this video, for this architecture, I want to deploy this containerized Docker image inside a public subnet, meaning I'm giving this service direct internet access to outside. Now, is it the best thing to do? For sure not. But it's the simplest form of architecture because that's the main of this video. For now, we're just going to start learning how we can use the AWS services to deploy a backend, to deploy a container. And then in the next steps, in the next videos, we are going to see how we can have the same containerized backend put in a private subnet, and how we can then provide the communication between other services. So in this video, we are going to just work with the public subnet, and we are providing direct internet access for our container. Now, let's first make things production ready. What do we mean by that? In the previous video, we created a Python script using Flask, right? We used Flask to create this Python script. Then we created an image from that script, and all it did was that it would read the route, and then based on the route of the HTTP that arrived, it would do some calculation, right? Calculation. Now, is this the best form we can have a Python backend on the deployment server? For sure not. Why? Because when we do so, we are going to let the user interact directly with the Python script, meaning we are not utilizing all of the resources available on that container. But with using a green unicorn, or let's call it Gunicorn, we are going to first create a server. What's the point of this server? It's a web server gateway interface for HTTP requests, right? So basically, all it does, it receives the HTTP requests, and then it interacts with the backend and then replies the responses. Now, there are two terms that are really useful in the when you want to use all of your resources in a container or in general on your server. And it's the number of cores that you have on your CPU. So for example, when we use the Gunicorn, Gunicorn, we declare how many cores we want to use. And then for each of those cores, we can define different threads. For example, if I say I need the number of workers to be equal to 2, and then I want to have the number of threads equal to 4, this means that I want to have 2 cores, and inside each of them I would like to have 4 processes done all at the same time. This means that at each moment we can be sure that this container can process 8 requests. Now, why are we just using, for example, 8? Why not use 1,000? Well, for sure we can do that, but this requires higher resources. So we have to increase the number of cores, increase the RAM, increase the storage in order to provide the infrastructure for these threads and workers. So that's how you make a Python backend by the term production ready, right? By having a web server gateway interface interacting with the user directly. And that's how you manage your resources on your Docker containers. Now, let's say we have the Docker image, right? We have wrote the script, we have used the Gunicorn, we've made the image. Now what? Now how we can use the AWS services? We have two main components here. 1, 2. The first one is called ECR. It's basically a repository. It's a place where you can store your images, right? And that's it. You put your images here, and then later you can recall them, and then later you can use them to start your containers. So the first one is ECR. The repositories could be either public or private, meaning you can have public access to the repository, or you can make it private in order to have more security on your infrastructure. And then we have the ECS, or the Elastic Container Service. The ECS is going to take the image from the ECR, and then it's going to run that image on a server, on an infrastructure, right? With some CPUs, with some RAMs, and then with some storages. So the ECR will just store the images. The ECS instead will run those images. We have two different methods of deployment when using ECS. The first one is using EC2 instances, very typical. You go with an EC2 instance, and then it's just like renting a server on the cloud. You just run the commands, and you have your container working on that infrastructure. The other solution is called Fargate, which is our choice for this video, and it's called serverless. I'm going to do a complete video on what is serverless, how we can use serverless, and when we should use serverless. But just to give you the big picture of what this method of deployment does, it's that it's the managed solution. Whenever you hear the term managed, it means that AWS will do most of the job for you. So you don't have to worry about what's happening inside your infrastructure. With the EC2, you have, as I said, you have some infrastructure, you have some CPUs, you have some RAM, and then you also have the access to them. Why? Because you have specifically chosen an EC2 instance. It's a server running just for you. So you have more control over what's happening also inside of it. With the Fargate, you don't have that choice. So you don't even worry about it. You just choose the amount of RAM and then the number of cores that you would like to have for this container, and it's done. It's super easy, and it's at most of the time it's more efficient, because also efficiency is one of the main components when designing different architectures on AWS. So what did we say? We said that we have the ECR, which stores the images, we have the ECS, which deploys them, and then we have two different methods of deployment, right? Now, let's say we want to deploy this image on ECS. How we can do that? On the local host, it was super easy, right? We had the image ready. We have like this image ready. We took it, we put it in a container, and that's it. That's what happened on the local host. But on AWS, it's a bit more, let's say, difficult. It needs more management. Why? Because when we work with containers, we don't want to focus on what's happening inside the infrastructure, right? And that's why I said that Fargate, this one, Fargate is a better solution. Because when I work with containers, I just want to be sure that the containers are working, the number of desired containers are the one that I need, and I'm good to go. I don't want to worry about what's happening inside the infrastructure. And that's why we have more options. We have more properties that we can manage when working with containers on a deployment basis. So first we have a cluster. The cluster is basically the container, right? We have a huge cluster, and then we can do everything inside of that cluster. Then we have something called task definition. Task definition is the blueprint, is the it's like the model. It's like the what you wish to be deployed on your cluster, right? So you define it outside. It's not related to anything. You just go to your console. We're going to see it very soon. You just go to the console. You're going to say, I want this image. I want to have this number of CPU cores. I want to have this much RAM. And this model, this, let's say, blueprint, is going to be stored as the task definition. And then later, I can create services. I can create a service inside the cluster, and I can say, look, I have this cluster. Inside of it, I would like to have 3 task definition tasks, let's say, running. Let me say it like, let's go from the other way around. Each box inside of the cluster is called a task. It's a task service. And then the combination of these task services is called a service. So for example, I can say, look, this is the backend, right? Let's say this is the Python script. This is the Python backend with the Flask. And I know that, for example, during the night, not so many people are going to visit my website. So I'm going to use just one cube here. It gives me management control. It gives me the ability to control the number of tasks I want to have based off what I need, based off what's my desired number of task services. So I go with the task definition, I create the blueprint, and then I create the service, and I declare how many of those tasks I would like to see in my service. And that's it. So we saw what was ECR, we saw what's ECS, and then we can just go with the deployment. Let's do this. Let's use Flask, since we already worked with it in the previous part of this video. Then we're going to also add this Gunicorn to this Flask to make it by the term production ready. And then we have a complete script. Then we're going to create a Docker image. We're going to store that image on ECR. We're going to push that image to the depository. Then we're going to create the VPC, the network, create the public subnet, and then we're going to give public access to the services deployed inside of it, which is for us the ECS. We're going to create the cluster, we're going to run the container, get the public IP, and then by the end, we would like to have the user putting the IP and then having the response as a HTML on the browser. So it's a very simple task to have a user see something on the internet. It's like it's the simplest form of communication or architecture you can find. But all of these gives us more management control. We can manage how we want the users to be able to interact with the backend. So this would be it for the theory part of this course. In the next part, we're going to have a look at the backend, and then we're going to deploy it on AWS. So stay with me and let's go. So let's get hands-on with the AWS. We have a very simple backend here. It's just going to listen on this route, on the root route, and then it's going to reply hello from ECS Fargate on the local host. We have the requirements, which are the Flask and also the Gunicorn. And then we also have this Docker file. I'm not going to go too much details because I already spent a lot of time in the previous part of this video series. So if all of this is new for you, go and have a review on the first part, on part 1. I'm going to take the Alpine as my base image. I'm going to create this directory. I'm going to copy this file into the image, install the dependencies, install the app.py and also all of the files basically in my directory to the image, expose this port, the port 8080, and then I'm going to run this command, which basically says, use the Gunicorn as your web server, bind it to the localhost on port 8080, and then interact with the app.py that we created, use 2 cores, and for each core use 4 threads. So basically it's going to manage 8 requests at each time. So we have everything set. We can go to the AWS console. So this is an old one. Let me just clean it here. So let's go to ECR, which is the repository for our Docker images. I'm going to create one. I'm going to call it, let's say, Flask ECS backend. You can either choose it to be mutable or immutable, meaning it can be overwritten or not. I'm going to go with mutable. And then you can also choose how you want the image to be encrypted on the repository. But I'm going to just go with the default settings, and I'm going to create the repository. And then we have to basically send the image from our local device into this repository on AWS. But how? First thing first, we need to install AWS CLI. What is it? So in order to install it, you can just search install AWS CLI and choose the first link. And then based on your OS, you can basically install it. It's super easy. But what does it do? So basically, it allows us to send API requests, or let's say it allows us to interact with AWS services from the terminal of our devices, which makes things so much easier and faster, right? So you're going to first install the AWS CLI, configure it to your account. Basically, you are going to give it your credentials so that it knows which account it's going to send and receive the API requests. And then when you come into your repository that we just made, here we can see the view push commands, and it basically has created all of the commands we need. So I'm going to choose the first one. I'm going to come here, I'm going to open a terminal, and I'm going to paste it. So what does this command do? This command is going to give us a temporary token to allow us to interact with AWS services through the terminal. So basically it's like we've logged in. We've used temporary credentials in order to log in into the AWS account. Then the second one. The second command is just going to create the image based on the instructions in the Docker file for this Python script. It's going to name it Flask underscore ECS underscore backend, which is the name of the depository. So it's going to install everything. Done. Then the third one is going to add a tag to this image. So it's going to take this image that we just made, it's going to change its tag so that later when we send it from our Docker engine into the ECR, into the repository, it can be found, it can be seen by the ECR. So I'm going to change the tag. So basically by now we only have created two images. This is the first one. This is exactly the same image but with a different name, with a different tag. And then for the last part, for the last part we're going to push this image, and it's going to be available. Done. Now if I come here and I do a refresh, I have my image ready in the ECR. So first step done. We've created the image, we've used the Gunicorn, and we have pushed our image into the ECR. How? With these commands, which needed us to first install the AWS CLI. So next step, let's create the VPC. Let's do that. Okay, so in order to keep this video as short as possible and not go through all of the things I explained in the part 1 of the other course, the Master Your VPC on AWS, I've already made everything and I just want to go through them. So I created a VPC with these ranges of values, and then I created a subnet for that VPC. I chose 16 IP addresses for that subnet. I created an internet gateway. I attached it to this VPC. I created a routing table and I associated it with the public subnet. And then I added this route which says for any destination, all you have to do is just go through the internet gateway. Now I ask you again, if you don't know what I'm talking about, go and watch that video. We go through the same things in that video. It's super easy and I'm sure you're going to enjoy it because I made that video block by block and it's really interactive. So the only thing missing here is the security group, which I'm going to create for the container, which allows the container to know. It's like it acts as a firewall for the container. So I'm going to say it's a ECS Fargate Flask security group. It's going to allow on port 8080. Okay. I'm going to choose the VPC I just made. I'm going to add a rule to allow on port 8080 from who? From anyone. And the outbound rule can also be like this. It allows any traffic from anyone. Okay, and done. So we have all of the components for our communication ready. We have the VPC, we have the subnet, routing table, internet gateway, and the security group. So we have also the image on the ECR, and the only parts remaining is to go and deploy that image on a container and interact with it. So on the next step, let's go and work with ECS. Okay, so we are ready to deploy our first container on AWS. As I said, first we have a cluster, and then we have task definitions which act as the blueprint, and then inside the cluster we define services, which then the services define the desired number of task services, which are basically the computational powers. So I'm going to start easy. I'm going to create a cluster. I'm going to name it the backend ECS Flask. I'm going to choose AWS Fargate. It says serverless, and that's it. So I created a cluster. It takes a bit of time for the cluster to be made, right? So in the meantime, I'm going to create my task definition. This is an old one. Okay, let me just create a new one for now. So I'm going to create a task definition. I'm going to say it's the backend Flask task definition. Again, AWS Fargate. I'm going to go now. We have to choose also the infrastructure, right? So I'm going to go with the Linux. I'm going to go with, let's go with 2 cores. Let's go with compatible. Let's go with 4 gigabytes of RAM, and I'm going to give it this role, which allows it to interact with ECR to get the image. I'm going to go, so here I'm talking about the infrastructure of the image of the container that I want to be created in the cluster, right? So done with this part. Name of the container, I'm naming it backend Flask container. Now we have to choose the image that we have. I'm going to browse, choose the repository, choose this image with the latest tag, select it, and then I'm going to, okay, it's on port 8080 TCP, and that's it. Yeah, that's it. So no management for now. I'm just saying what do I wish to see in the deployed container. So we have not created anything for now. Now this is an old one. I created this I think yesterday. I just wanted to try something with the Flask. So this is the new one. This is the one that we created with this image. So I'm going to go to the cluster. It has been made. Here we have the services and we have the tasks. So let's create a service here. I'm going to create a service. I'm going to choose the backend Flask task dev that we just made. Okay, the name of the service could be the backend service Flask, and then it's based on the Fargate. And here it asks how many tasks I would like to be deployed. So I can, for example, if we want to be like very detailed about it, for example, there are times, let's say our backend is going to handle an e-commerce shop, right? Let's say it's going to route the requests arriving for Amazon.com. If it's during the night and there are no offers on the website, there's not going to be that much traffic. But let's say it's near the let's say Halloween, and many people are going to get some dresses, they want to buy stuff. So that's when we can increase the desired number of tasks in order to have a response for the large amount of requests that are arriving inside our backend. So that's desired tasks. Then We have availability zone rebalancing. I'm not going to use this right now. I'm going to show it in the next video when we are going to put the container in a private domain, in a private subnet, and then I'm going to put a load balancer inside the public one. And these two here, they're going to define how the load balancer inside the public subnet can interact with the container in the private subnet. So for now, I'm not going to worry about these two. Why? Because I'm going to deploy the container in a public subnet. I'm going to give it public internet access, which is for sure, I don't think anyone is going to ever do that on deployment. It's not secure, it's not scalable. There are so many problems with this architecture, but it's the simplest form of a deployment that we can do, since we just wanted to see how we can have a container on AWS. So I'm going to choose networking. This one is important. Choose the VPC that we made. Choose the subnet that we made. I'm going to use an existing security group. Which one? This one, the one that we made, which allows traffic on port 8080. And then I'm going to give it a public IP, and that's it. So what happens right now? I have a cluster. It's going to create one service with one task service, and in the end, we're going to get the IP of the task and be able to see the results. So I'm going to create it. And I have to say, working with ECS can sometimes, like it says, it takes a few minutes. It's not that fast to scale, because getting the resources, installing everything, and having the states change is a bit time consuming. So we have the service here. It's active. Still 0 out of 1 tasks are running. Why? Because it's in the in progress deployment. So this task running is the same task that we have here. If I come here, it's in pending state, but the desired state is running. So it's going to change from pending to running. And there is only one. There is only one task. Why? Because we said the desired amount is 1. So all we have to do is wait here. Now it's running. Perfect. Okay, we have the security group with Fargate, with 2 cores and 4 gigs of RAM. It's a bit too much for this very basic backend, but I just wanted to choose something. And if I go inside of it, go into networking, I can see the public IP now. So basically now we hope that if I come here and I do 8080, I'm going to get a response, the hello world message. Done. Perfect. Hello from ECS Fargate Flask. It's the same message that we put here. So we have gone into the on port 8080 on the root route, and we can see this image. And now you can see how much more difficult it is to have codes running on your own computer be useful on the AWS infrastructure. It needs so much more services because everything has to be managed. Everything has to be calculated, because with any choice comes the problem of pricing, security, availability, and all of the other terms. So that would be it. So now we have the container running on AWS. Now this could be anything. It's just a simple message. It could have been a website. It could have been a large amount of calculation. And yeah, that would be it. So again, I'm very interested in these series of videos, because I'm trying my best to make things as simple while going in a very, let's say, short steps. I don't want to like give out a video with the most with the best practices of different architectures on AWS, and because that then no one would understand what's happening, right? So I want you to understand each step and follow along with me, and then I'm sure, like, after a couple of parts, we are going to be able to create one of the largest production services ready to be used for your own project or for your later use. So thank you so much. I would like to ask you to subscribe to the channel and also like the video. It really helps me. And then if you have any questions, you can either, I'm not going to say ask me first, do the ChatGPT. Search for it, ask ChatGPT. And then again, if you still have any problems, you can always reach out to me through the comments. Thank you so much. I hope to see you soon again. Take care. Bye bye.